The structural performance of a die casting usually depends on four mechanical properties: modulus of elasticity, tensile strength, fatigue strength, and impact strength. The modulus of elasticity is not affected by casting parameters. Therefore, analytical methods or computing stress and deflections to the yield point can be applied to die castings. Ultimate tensile strength and yield strengths may be affected by casting parameters, and some alloys are more affected than others. Designing die castings to published stress levels is not usually recommended unless the design anticipates that wall thicknesses will be increased in critical areas and allow for the die casting to be modified as needed. Where strength of a feature is critical, it is essential to work with the die caster to establish the levels of performance that can be achieved and agree on the test and inspection procedures for maintaining the required strength.
Die casting alloys do not reach a distinct endurance limit as do steel alloys. Published values for endurance limit specify a very high number of cycles of fully reversed loading, typically 500 million, beyond which there is very little decline in stress level at failure. Fatigue is affected by porosity. Minute cracks that initiate fatigue failure begin more readily at individual pores. Die casting process controls that reduce porosity improve fatigue performance.
Impact failures are very difficult to predict by analytical methods, usually because the inputs cannot be quantified. Published values of impact strength are primarily used to predict relative performance of two alloys in a given application. Two other categories of structural performance relevant to die castings, which are not readily handled by standard methods, are creep relaxation, and dent resistance, which will be covered in the next modules.